Welcome to Probability and Statistics. In this lecture video, we're going to talk about Chapter 5.1, something called a discrete random variable. Alright. By definition, what is a random variable? A random variable is referring to a variable whose numerical value is determined by the outcome of a probability experiment. Alright. So in this chapter, we're going to in this section, we're going to talk about how probability is related to the things we talk about in the lecture video series with chapter 3. All those things that we did in the calculator. Alright, so we started with the wording called the random variable, whose numerical value is determined by the outcome of a probability experiment. Now, we talked about the word distribution before, okay? Now we're going to add the word probability in front of it. So what is called the probability distribution is referring to a table, formula, alright, that gives the probabilities for every value of your random variable x, where the probability again is between 0 and 1, and the sum of all probability will equal to 1, just like in chapter 4. Now, so for example, if I want to flip a coin 2 times, the sample space, as I mentioned before, will be heads, 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 tail, tails, heads, and tail, tail. All right, so we got four possible outcomes. So rather than asking what's the probability of getting a head and the tail, which is half, we may only be interested in talking about the probability of just getting a head. So if I want to get just heads, my possible value of getting heads, which becomes my random variable, I can get 0 head out of the 2 flip, I can get 1 head out of the 2 flip, or I can get 2 heads out of the 2 flips. So we are changing our L1 or the x-axis into the number of heads. Alright, so what is my probability of getting 0 heads? So if you look at the sample space, okay, out of the 4 possible outcomes, the chance to get no head got to be referring to getting both tails, so that got to be 1 out of 4. Alright, so that means there's a one way to get 0 head out of 4 possible outcomes. To get just 1 head, that will be head, tail, and tail, head. That got to be 2 ways out of the 4. To get 2 heads, that will be 1 way out of the 4. So I can write them as in fraction form, or I can write them as decimal form. So that will be 0.25 for getting no head. 2 over 4 is the same as 1/2, which is 0.5. And 1/4 is 0.25 again. So if I will sum up my probability, so all these decimal answers becomes a probability. Alright, back in chapter 3 was under the L2 or the y-axis. Okay, normally we use frequencies. Alright. And the L1 is your class. So rather than having class and frequency, now we are transitioned into random variable x. L2 is now becomes your probability. Remember now, probability can be used. We can use fractions or decimal answer for probability, which is just like the relative frequency that we talked about in chapter 2. Alright, so that's the transition. So that means we're going to talk about probability along with the things that we did in the calculator that you learned from chapter 2 and chapter 3. Alright, so this is my answer right here. What is the probability? Okay, so what's the probability of getting just heads? So these are the probabilities. Alright, so let's try again. Construct a discrete probability distribution for the random variable described. The number of heads in a 5 toss of a coin. So I want to toss the coin 5 times. So what I could get is either 0 heads, 1, 2, 3, all the way up to 5 heads. Let me move this out a little bit. Alright. I can get all the way up to 5 heads. So let me add another table here. So if I want to toss a coin 5 times, 1, 2, 3, 4, 5. Every toss has 2 possible outcomes. One task followed by the other. So so we multiply. So let's go back to our fundamental counting principle. So 2 to the 5th, I believe, is 32. So that means there are 32 possible outcomes. Alright, so how many ways, what's my probability of getting 0 head? So that would be how many ways I can get 0 head. So that would be 5 coin toss, choosing 0 head using combination. Alright, same thing for the 1 head. So that will be 5 choosing 1, 5 toss choosing 1 head. Alright, for 2, let me put it right here, okay, line them up. Let me go ahead and delete that. I just wrote that for you to see. Alright, 5 choosing 0, 5 choosing 1, 5 choosing 2 heads. Five choosing 4, excuse me, 5 choosing 3, 5 choosing 4, and 5 choosing 5. So that's how we count. Okay, how many ways I can give 0 head, 1, 2, 3, all the way up to 5 heads. Alright, so let's put this in the calculator real quick. Combination 5, math, probability number 3, combination. Choosing 0 head. 0 head means all 5 toss got to be tails. There got to be only one way. Alright, 5 choosing 1 is 5 ways. 5 choosing 2, gotta be 10 ways. Alright, so 10 ways I can end up with 2 heads out of 5 toss. 5 choosing 3, which is another 10 ways. 5 choosing 4, 4 heads, that means one of them is tails. So if I would change the random variable to be tails, 5 choosing 1 tail going to be the same answer as 5 choosing 4 heads. Okay, it's actually saying the same thing. That's why my answer is 5 again right here. So you can begin to see the pattern. 5 choosing 5 got to be one way, because if all 5s are heads, okay, it got to be just one way. Same thing as if I was saying 5 choosing 0 tails, which is all heads, got to be one way. That's why the pattern exists. Alright, so my probability, my chance of getting 0 head got to be one way out of 32. Okay, I think this problem wants me to use a simplified fraction. This is the next one is 5 ways out of 32. 10 ways out of 32. If I was simplify the fraction, reduced by 2, that will be 5 out of 16. So the next one is the same thing. 10 out of 32, which is 5 over 16. 10 ways out of 32 possible outcomes. And I got 4 is 5 ways out of 32. And 1 out of 32. Alright. Okay. So, discrete means something we can count. We talked about that definition a while back. So I can count a number of heads from 0 all the way up to 5. You know, something I can count, it is finite. Okay, the most I can get is 5 heads, and I can figure out the probability of each one by using combination. All right. So now the next topic will be something called the expected value. The expected value for a discrete random variable x is equal to the mean of the probability distribution of x. Expected value is referring to the mean of the probability distribution. So expected value using the capital letter E of the random variable x is equal to the mean of the random variable x. This is how we this is the notation we will write it, which is equal to sum of all your entry, your xi entry, you know, the 0 head, 1 head, 2 head, times the probability. All right. So if I have x1, x2, x3 all the way up to x5 be the value of a random variable after each experiment, okay, then the mean, all right, and the mean, excuse me, I say this wrong, the x1, x2, x3 yeah, I was correct. All right, the xi is my 0 head, 1 head, 2 head. All right. Normally, when we find mean, we add them all up, divided by so many we added. Okay, so eventually your x bar, this is very important, eventually your simple mean will become the mean of the random variable x. Okay, so what's happening, what it's trying to say, which is all very similar to the law of large number, is if the number of experiment of n increases, if I keep on doing the experiment, keep on doing the experiment, eventually, all right, my simple mean will equal to the mean of the population for the random variable x. Okay, so what does that really mean for us? All right, is that if you look at this formula, the expected value, what it's saying is, if I will multiply, okay, if I will multiply my each individual xi times its probability, okay, and add them all up, eventually it will equal to the mean of the entire distribution. All right, so if I will take a 0 times the 1 over 32, I will get 0, which we expect that. Let me put this in red so we won't get confused. All right, 1 times 5 over 32. 1 times 5 over 32. If I will multiply my random variable with the probability, this is 0.15625. Two times 5 over 16, which is 0.625. So this is going to be 0.625 again. This is going to be 0.15625. 5 times 1 over 32. 0.15625. Ooh, sorry. I made a mistake with the fourth one. think 4 times 5 over 32. 0.625. I'm sure I did for the 3. I don't think I did for the 3 either. Jumping the gun a little bit. Three times 5 over 16 is actually 0.9375. I think I did the 2 earlier. Just make sure I did it. 2 times 5 over 16. Alright, so if I add up all these probabilities, 0 plus 0.15625 plus 0.625 plus 0.9375 plus 0.625 plus 0.15625. Alright, so that means my expected value 2.5. So remember, my random variable x representing getting the number of heads. So out of the 5 toss, okay, I am expected, if I flip a coin 5 times, I am expected in the long run to get 2.5 heads. Okay, to get 2.5 heads, which is half of the 5 toss. Okay, same idea. Let's call the expected value. So this is the same thing as the mean of the distribution. So what this thing is saying is, if I do a probability experiment, okay, as my experiment increases, the sample mean will eventually equal up to the mean of the probability distribution for the 5 tosses. So I can experiment where I can actually toss a coin, all right, many times, okay, maybe like 1,000,000 times. Eventually, okay, it will give me the number of heads. What I'm expected to get is about 2.5, okay, which is half of what I'm supposed to get, okay, because probability of getting a heads or a tail is half anyway. All right, this is a very interesting problem. I want to talk about this problem, and then we will do some from the textbook regarding to your expected value. So let's say this New Jersey Pick 4 lottery game. You pay 50 cents to select a sequence of 4 digits, such as 1332, for example. If you select the same sequence of 4 digits that are drawn, you will win and collect $2,788, for example. All right, so how many different selections are possible? All right, I'm going to select 4 digits, and as you can see, that 3 and 3 right here in the example they gave me allow me to use, okay, the same digits. So repetition is allowed. So each digit I should have 10 to choose from. So one test followed by the other. So that will be 10 to the 4th power, which is 1 with 4 zeros. So I have 10,000 different selections that are possible. So what's my probability of winning? My winning sequence can only be 1 out of that 10,000. Okay, ways I can select. So if you win, what is your net profit? Net profit. My net profit got to be, well, if I win $2,788, right? But to win, I got to pay 50 cents. So minus 0.5. So that will tell me my net profit got to be $2,787.50. Okay, that will be my net profit. find the expected value. Alright, so here we go. Find the expected value. So my random variable x. Alright. My random variable x. Got to be my win or loss. Got to be referring to the money. So I'm going to put this in red. So if I will play, I will lose. Well, you know, I got to pay first, so that's 50 cents. What's it? Negative 50 cents. I'm going to put that in red. Alright. Or I can win. Then if I win $2,787.50. Okay, and put that in green. You know, like the money, green. Oh, make it a little bit darker green here. Alright, so that's my random variable. Losing the 50 cents or winning the 27.87 cents. Now, my probability for my random variable x. Alright. What is my probability of losing? Well, if the winning is 1 way out of 10,000, that means the losing got to be 9,999. So I have that many ways to lose out of 10,000 ways. Alright. The chance for me to win got to be 1 way out of that 10,000. Okay. So I'm basically trying to follow the formula that I wrote down earlier. Okay. To the xi times the probability. So now if I take my random variable x and times the probability of the random variable, let's give it a try. Negative 50 cents times the chance of losing 9,999 ways out of 10,000. That is practically negative 0.49995. Alright, that's 3 nines. Okay, very good. Alright, so this is negative. Put it in red because I'm just lost money. Alright, the chance of winning 2787.5 times the chance of winning 1 out of 10,000. Point 287 2.27875. So if I 0.27875, put that in green. Alright. So what's my expected value? My mean in the long run is where I see I multiply my random variable x times the probability, and at the very end I got to add them all up because the summation sign here in front of the formula tells me to do that. So if I take the negative 0.49995 plus 0.27875, my answer will be negative 0.2212. negative 0.2212. So what that tell me is my expected value in the long run is to lose about 22 cents while I play this. Okay, that's how lottery, that's basically how lottery, works. Okay, when you play, alright, when you play, sometimes you win, sometimes you lose, but the expected value in the long run, if you keep on playing the lottery game, keep on playing, keep on playing, keep on playing, in the long run, the true expected value, the true mean, tells you that in this game you will lose 22 cents. Okay, so you pay 50 cents to play and you're expected in the long run to lose money. Okay, and if you're not expected to lose money, then the lottery company is not making money to do the payouts. Okay, so most of the time when we do gambling games, all right, in the long run we are actually expected to lose. All right, so the example I'm going to show you what we can do rather than just compute this calculation every time. I think we can put them in the calculator. Okay, I'm going to try to put this in the calculator. In the long run, which plan has a better payout? So rather than multiply your random variable x, the payout is a random variable x. This is the probability of payout. All right. So rather than multiply them and add them up, what I can do is put them in the calculator, because expected value that I just found is the same thing as the mean of the distribution. So what we can do is go back to stats, under edit. Let me clear this out. Type in my payout under L1, negative 25,000 and positive 20,000 and a 90,000. Alright, L2, type in the probability, 0.06, 0.69, 0.25. Alright, so as you can recall, after we do stat, after we type it in, we go back to stats, highlight the word calc, choose number one variable statistic. Now I just type in numbers under L1 and L2. So here I will say second L1, comma, second L2. And what I'm looking for is my mean. Alright, my expected value for this game is 34,800. Alright, that's the plan A. Alright, let's see what plan B is. What's the expected value? So we are comparing between the mean in the long run, which is the expected value. So I'm going to go back under edit. Alright, negative 20,000, 45,000, 65,000, 0.31, 0.31, 0.38. Alright. Stat, calc, number one variable statistics, do L1, comma, L2. 32,450. Alright, so which one has a higher payout? Which one is a better plan? My answer will be plan A. Plan A has a better payout. Okay. Alright, let's try some example. Okay, let's try some example. We're gonna try to use the calculator to help us out. So let's say we're gonna throw two dice. If the sum of the two dice is 5 or more, you're gonna win $30. If you're not, you're gonna pay me $161. find the expected value of the proposition. Alright. Round your answer to 2 decimal places. Loss must be expressed in the negative value. Okay, so now before I begin, let's think about this. The sum of 2 die is 5 or more. You win $30. So 5 and more, you win. So what's my lost? My lost got to be the sum of 2, 3, or 4. Okay, so let's figure out how many ways I can get the sum of 2, which is one way, right? 1 and 1. Alright. Sum of 3 got to be 1, 2, and 2, 1. Sum of 4, if you count 1, 3, 3, 1, and 2, 2. Okay, so that means I have 1, 2, 3, 4, 5, 6. I got 6 ways to lose. Maybe it's a little smaller. 6 ways to lose. So from the project, as you can recall, when I roll the die 2 times, there are 36 possible outcomes. Alright, so my random variable x, the payout, just like the previous problem, the payout, either you win $30, because I'm going to create this table, maybe I can use it again in a minute. You win and you lost. Alright, so the payout is either $30 if you win, which again I'm going to put it in green, or you're lost, negative $161. I'll put that in red. Alright, what is your probability? Of the payout? Alright, let's see. Probability of the payout, you win. So there are 6 ways to lose out of 36. So losing is 6 ways out of 36. Okay. Winning got to be the other 30 ways. Out of 36. Alright. So that being said, rather than do this by hand, I'm going to put it in the calculator. Go back to stats, edit. I'm going to clear out my L1 and L2. I win $30 or negative $161. The chance of winning is 30, typing 30 out of 36. Chance of losing 6 out of 36. So if we're typing like this, it automatically gives me the probability of winning and losing. Alright. So it looks like I got a lot more ways of winning. So stat, calc, one variable statistic. Let's do second L1, comma, second L2. My expected value, negative 1.83. So my expected value for the random variable x, negative 1.83. So that means I am expected to lose $1.83 every time. Okay. So, step number 2. So if the sum of two dice is 5 or more, you win 30. If not, you pay me 161. So let's say you play this game 794 different times. How much would you expect to win or lose? So if you're just playing one time, you expect it to lose $1.83. So if you play 794 times, so take 794 times your losing negative $1.83. That will tell you 794 times, excuse me, negative $1.83. You're expected to lose $1,453.02. So you're expected to lose. So if I would say, no, you play this game, every time you play, you pay me $2. Okay, so every time you play, you're expected to lose $1.83. There are sometimes you will win. Okay, there are sometimes you lose, but in the long run, you are expected to lose $1.83 every time. So if you're playing at 794 times, you're gonna end up losing $1,453.02. Okay. Alright, that is how the game is played. If the house does not win, there's no point for them to even have the game. Okay. So, like I mentioned before, gambling is supposed to be fun. Okay, gambling is supposed to be fun. It's not something that we play constantly. It's just something we play once in a while just for fun. So be careful, be careful. Alrighty. Let's try another example, okay? Let's see if I can get out of these guys. Let's try another one. Alright, so let's say if you draw 2 hearts on 2 consecutive draws without replacement from a standard data card, you win 740. Otherwise, you pay me $45. Find the expected value again. Alright, so let's think about this. Okay, the payout, you win $740. You lose if you pay me $45. So this example, you know, the win and losses is big swapping here. Alright, so what is the probability? Draw 2 hearts on the consecutive draw. So that will be heart and the heart. Your probability of getting a heart without replacement on the first, the number of ways to get 2 hearts, or the first draw, there should be 4 ways to get a heart out of 52. Followed by, I'm gonna get another heart times, alright, without replacement. So that means the second time, you only got 3 ways to get a heart out of 51 possible outcomes. Okay, so that is your probability of winning. Alright. Probability of losing. Your probability of losing got to be 1 minus the way of winning. Okay, I hope that makes sense from the complement rule. Rather than for me to refigure out all this, I can figure out the probability of losing by the complement rule, which is going to be 1 minus, copy this, 1 minus why just in a minute when I want to put this in the calculator, I would just be a little bit careful. Okay. Alright, let's put it in real quick. Stat calc. Alright, win 740. Or lose, that's negative 45. Alright. My probability of winning, parenthesis, 4 out of 52 times 3 out of 51. That's my chance of winning, 0.00 something. Losing, 1 minus, parenthesis, 4 out of 52 times 3 out of 51. That's the number of ways. That will be my chance of losing. Stat calc number 1, second L1 comma second L2. Simple without replacement. Did I put it on right? If I draw 2 hearts on 2 consecutive draw without replacement, you win something. If unexpected value, make sure I did it right. Sometimes I might typing it wrong. 4 out of 52 heart back to back without replacement times 3 out of 51. Okay, so 1 minus that. 1 minus second A and S. 995. Yep. So if I do, so I think I typing it right because my answer is a little bit off. If you win, it's 740. If you lose, that's $45. So I do stats calc. Second L1, comma, second L2. It shouldn't be negative. That's the part I'm not quite sure what I did wrong. It should not be negative. Because even though my chance of winning is very small, times by that 740, times by the 740, that will actually give me more positive. If you draw 2 hearts on 2 consecutive draw, so that's, oh, I'm sorry, 2 heart. I was thinking about aces. I apologize. Oh Lord. I was thinking about ace the whole time because there are 4 ways to draw an ace. Hearts. Alright, sorry about that. There are 13, excuse me. Yeah, there are 13 ways to get a heart on the first draw. The next one should be 12 out of 51. And I apologize. I was wondering what I was typing it wrong. I don't know why I say 4 hearts. I was thinking about ace. Alright, let me type in this again. Ooh. Alright, so 13 out of 52 times 12 out of 51. That's it. 1 minus 13 out of 52 times 12 out of 51. Okay, let's try it again. I apologize. I was thinking about ace the whole time. L1, L2. Alright, 1.18. So you expect the value? 1.18. It's positive because, okay, it's actually not to be positive because I believe it got something to do with this. Okay, the payout. Probability of winning might be small, but the payout is big. So when you take the payout times the chance of winning, okay, this decimal can be bigger than the losing. So that's how we add them up. Still end up to be positive. All Alright, let's do another one. I apologize. Didn't do my probability experiment correctly. Alright, so we played this game 756 times. So that will be 756 times my probability, excuse me, my expected value, which is win $1.18. 756 times 1.18. Alright, so I expect to win $8.92 and 8 cents. Alright. Order into 2 decimal places. 8.892. Oh. Alright, let's try this one. Now, if my answer is slightly off, okay, that got something to do with me typing all these probability into the calculator at one time. Because when I do that, I'm actually not rounding. I think the calculator, excuse me, I think that the Hawks Learning sometimes round the probability to 4 decimal place. So if you find yourself a little bit short, okay, that means you got to type this out in the calculator and then round 4 decimal place. Right now I'm just not. Right now I'm not rounding it. I can round the next one. That's fine. Alright, flip a coin 12 times. If you get 8 heads or less, I will pay you $4. Otherwise, you pay me $37. Okay. If you get 8 heads or less, ooh, let's look at this game. Alright, the payout is $4. If you lose $37. Okay. 8 heads or less. Oh, that's a lot of work. 8 heads or less. 8 heads or less, you win. Alright, so let's think about this. Okay. I think it's easier for us to figure out the lose first, because if you really think about it, when you flip a coin 12 times, you can get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way up to 12 heads. For you to win, we got to figure out the number of ways from 0 all the way up to 8, because it says 8 head or less. So that's the number of ways you win. So that means the 9 to 12 is when the number of ways you will lose. So I think it's easy to figure out the loss first. Alright, so let me do it down here before I go back up there. Alright, find the number of ways you can lose. So let's do the 9 scenario. Okay, the 9. We will toss 12 times, choosing 9 heads. That will give me the number of ways to get 9 heads, plus 12 choosing 10, plus, alright, 11 choosing, excuse me, 12 choosing 11, 12 head choosing 11, 12 toss choosing 11 heads, plus toss 12 times choosing all 12 of them to be head. That gotta be just one way right there. So all that, okay, is your ways of losing divided by the total possible outcome. The total possible outcome got to be toss a coin 12 times. Every toss has 2 outcomes, one followed by the other for 12 times. So that will be 2 to the 12. So this is gonna give me the probability of losing. So I'm gonna type 12 choosing 9 which is 220. Choosing 10, which is 66. 12 choosing 11 heads. 12. And 12 choosing 12. That'll be 1. Alright, I'm gonna add these up. Add all the ways of losing. So I got 299 ways to lose out of 2 to the 12 power. I'm going to just write 2 to the 12 power, but I'm going to type 299 divided by parenthesis 2 raising to the 12 power. Alright. 4 decimal places, that would be 0.0730. 0.0730. Okay, so that's the chance of losing. Zero 730. Okay. So my chance of winning gotta be 1 minus. So I will win if I do 1 minus that. Alrighty. So I would know. So rather than this is gonna round to 4 decimal places already when I type it. So let's go and type it in. Alright, win 4, lose -$37. Alright, chance of winning 1 minus 0.0730. 0.0730. Alright, stat calc number 1, second L1, comma, second L2. Alright, round to 2 decimal place, so that'll be 1.01. So you expect to win 1.01. Alright, so if we play 632 times, so 632 times my expected of winning 1.01, we expect it to win $638.32. Alright. So this one, even though the chance of losing is small, okay, even though the chance of winning is big and the payout is kind of small, but if you take the $4 times this big chance of winning, it will outweigh the losing. Okay, so that's why our expected value was a win. Alright, so now you know how we just find the mean. Now we can talk about the standard deviation and for the random variable and the variance. So this is just exactly the same thing as we done before in chapter 3. Alright, so find the expected value. Expected value is the same as the mean of the distribution. Okay, it's the mean as a distribution. So all we're gonna do here is just type it in like we've been doing, and then we will find the mean, standard deviation, and the variance. So -4, -3, -2, -1, and 0. Alright, my probability of each one is the same, 0.2. You can probably guess what the answer is. Stat calc second number 1, second L1, comma, second L2. Alright, so my expected value is -2. Of course, it's all the same probability. Alright, so sigma is the standard deviation. Standard deviation, if I round to 1 decimal place, my sigma standard deviation of the random variable x, 1.4. So to find variance, we just got to square it. 1.4 square it. If I round to 1 decimal place, the 6 will mean that my 9 to go up. So my variance, sigma squared of random variable x will be 2.0. Alright, find the value of the probability that is less than equal to -2. Less than or equal to -2. Want to find the probability. So the random variable is -2, right here. Want to be less than that. Less than that is go to the left. So all that, if you add it up, that will be 0.6. Alright, this one says find the random variable x that's less than -1. Less than -1. But we're not counting -1, so that would be -2, -3, -4. So if I add all those probability, you'll give me the same thing. Okay, so in this lecture video, we talk about what is so-called the expected value, which is basically is the same thing as the mean of the probability distribution in the long run. Okay. Alright, and then we kind of make a transition between how to use the probability problems and then write them out as a random variable, and we put them in the calculator just like we did back in chapter 3. Alright, and that will conclude this lecture video for the random variable. In the next lecture video, we're going to talk about a particular type of discrete distribution. This is just an overall view of random variable, but we're going to talk about one specific of discrete random variable in the next lecture video. Alright, thank you for watching.